Hi, folks. Will from MinIO here, and today I am chatting with Harsha, one of our lead engineers here at MinIO. And Harsha works a lot on object transform. So, Harsha, take me through the flow here. You've got three actors in an object transform. You've got MinIO, of course, and then you've got an application, and you've got a handler. So, how do those three things really interact with each other?
So, the Lambda transformations or the transformation of an object is more or less a feature that we kind of actually implemented for a specific customer requirement where they would like to transform the object that they're retrieving from MinIO in a specific form. Maybe they want to add a watermark, they want to add something new to the object, and that's how they want to possibly present it to their application. So it is a very specific requirement. And they are free to implement what they want in these Lambda handlers. So the flow is more or less like you would as an application just do a get object, like as you actually try to download an object. What you would do is additionally ask MinIO server to basically give me a transformed version of this object by executing or applying this particular function on it. Now, this function is basically nothing but a remote handler, where MinIO basically will actually ask this remote handler to actually download the object and run whatever the transformation that it may need to present the relevant object back to the client. So the overall idea behind is just being able to see the object and add some extra information to it, maybe even filter out some information that you don't want to be present, don't want to be shown to the application. Then there could be other things like, you may want to truncate, you may want to send a compressed version of the object, there may be change the format, like the object actually is in let's say a Microsoft Word. You would want a PDF version of it, so you can do all of that. So in a nutshell, this is pretty much Lambda transformation is.
Okay. So one of the things you mentioned in there is that MinIO is going to hand off to this handler. So it's not part of MinIO itself. So really, what are the benefits of having the handler be external to MinIO instead of built in?
So the main reason here is that the functions, we could definitely do it inside MinIO as well. There is no requirement as such, to not do that, but it is more or less like a design approach where what a storage server should do versus what the compute resources that you may actually have for the server. So you would want to separate these out as much as possible in terms of, like, say, for example, if you have a very specific requirement of transforming your object that may use up a lot of CPU, or it may even do some amount of some compute intensive work, you may want to actually run it outside the compute resources or even the constraints of your storage deployment. So you may want to actually run it in a farm of a lot of servers. Basically, you have a farm of Lambda handlers where you can actually send these objects to, they can transform them, send it back to MinIO, and that's where the MinIO will actually send it back to the client. So mainly to be able to separate out the requirements, that storage should basically just do storage as such. So that is what MinIO does. It doesn't want to run any other arbitrary functions on it. And you would actually run the arbitrary functions on a separate compute infrastructure. So that's where your Lambda handler will be running. So it's just primarily just that. And there are, of course, ways to do it within MinIO as well, but we took the approach of making sure these are the requirements that comes from a customer. They have specific requirements of how they want to do, how they want to transform the data, what kind of data do they have. So all of these are then specifically their requirements. So they will implement a Lambda handler of their choice, how they want the data to be presented back to the client. So the goal here is that we provide them all the necessary toolkits where they can actually come up with a Lambda handler that does what they actually want. So we have some documentation about how you can write these handlers. We have documentation primarily about how to use how to see the transformed object on a client. And the most important part here is to understand is that this is not a separate API, meaning it is part of the S3 API, a get object with a slightly additional parameter that you can pass. The parameter is primarily, you just say that, here is a query parameter saying, this is the Lambda function that we want to be executed on this particular object. So what it does is, fairly from a client perspective, client does a get object with this additional query parameter, it gets a transformed object at the end. Client really doesn't know either it is MinIO or is it coming from a Lambda handler, or however it is actually stitched together.
Wow, that's impressive. So you mentioned that this is all very client driven. This is what allows us to have this separation concerns. We're going to be a really great storage tool. If you want to be a really great transform tool, go ahead and be a great transform tool, and you can run over in your own compute center, right? So since you mentioned, though, that this is all very customer focused, which MinIO, we are very customer focused. We're very driven by that. But have you actually encountered any deployments of one of these handlers that has been really interesting for you? Only if you can actually share, but yeah.
Maybe a little bit, not a lot. We have a customer for whom we actually specifically built this, but it was also sort of available as part of AWS S3 API. So AWS S3 has kind of similar API, which is not, but we kind of implemented it based inspired by their implementation, but not necessarily an exact version of what they implemented. So in AWS S3, they have the similar kind of an API where you can do transformations, where the S3 layer, the AWS S3 layer, actually invokes a function on AWS Lambda, and these AWS Lambda functions are sort of pre-baked in on their infrastructure, and then you would invoke them in a sort of a similar kind of manner, like how you would do it on MinIO. But not exactly the same, but it is a fairly involved implementation. One thing we wanted to do on MinIO is primarily that we wanted to simplify this approach of Lambda implementation, and also make it easier for our on-prem customers to actually adopt this. So, and this customer had a very specific requirement. They wanted basically, they had a bunch of documents. They wanted to add watermark on it. They wanted to have pre-filled forms of certain PDFs. Like, for example, you have a PDF which has basically a lot of empty fields, but you could fill them up in your Lambda handlers and present a copy of a PDF where the information is already filled in. So in a way that like an automated fashion of using a single object as a template to generate various versions of the similar kind of an object. So it's those are one of the requirements of this particular customer. But there may be tons of other requirements, like, for example, antivirus scans. You may want to scan the object for any viruses before you send the object back to the client, back to the application. So yeah, there are just quite a lot of use cases. So that's just to name a few.
Yeah, I mean, I wish a couple of the institutions I've been working with in the last couple of weeks had that PDF autofill, because I've been having to write my name over and over and over again for no good reason. Well, this is fantastic information, Harsha. Thanks so much for chatting with us. And for those of you watching at home, thanks again for joining us. If you'd like to reach out with us, you can use any of the methods you see here on the screen. You can also reach out with us interactively on slack.min.io, or you can just leave a comment here on the video. Thanks. We'll see you for the next interview. And thanks, Harsha. It was great.
Thank you.